Okay guys, I'm really sorry about that and the fact that the camera cut out, it was losing battery and not so good. What I've done here is I've gone through and I've written in the y components after we did the x components. To solve for each y component, I would take the sine of the angle and divide by the hypotenuse. So the sine of 30 would equal y divided by 50 for the first one. Over here, the sine of 35 would equal y divided by 10 because these are our opposite lines. Now, I've also gone in and gone through and solved for x1, x2, y1, and y2. Now this is complicated and kind of crazy, so I think the best thing to do is actually fill out a chart of all of this information. So we have to think about positives and negatives. In both of these cases, for both the 50-meter line and the 10-meter line, we are moving to the east. So for both of them, the x's are going to be positive. We're going to see a positive 43.3 meters for the x component of our first vector, and a positive 8.19 meters for the x component of our second vector. In the y direction, however, we start off by going north and then come down by going south. So originally, our first vector is going to be a positive 25 meters, and our next vector is going to be a negative 5.74 meters. If you go back to your chart of how to mathematically solve, you're going to find that we need to total up the x's and the y's. Because basically what I'm saying is that instead of going 50 and then 10, I could have simply gone 43.3, then 8.19, then 25 north, and 5.74 south to end up back at this position. So my totals here are going to end up being 51.49 meters and 19.27 meters. Now these are going to act as the actual x and y component of our resultant. So over here I've redrawn my two vectors, trying to make this picture a little less complicated. Now I'm going to draw in my actual resultant. Again, I start where I started, I end where I ended. So this line would have been that. Now again, we said this is the x component, meaning I could have gone over 51.49 meters, and then instead of going 25 north and 5 south, I could have simply have gone 19.27 meters north. Now this creates a nice right triangle, and I can use Pythagorean's theorem. A squared plus b squared equals c squared to figure out the length of that path. So if I come in here, it would be a 51.49 meters squared plus a lovely 19.27 meters squared equals my resultant squared. Plug it into your calculator, make sure you take the square root, and you end up with a lovely 54.97 meters. Meaning I could have simply have walked instead of 50 and then 10, 54.97 meters. It would have been a little bit faster. Then, I'm not done. I still have to find the direction portion. So 54.97 is the first part of my vector, but I've got to find the direction. To do so, I have to think about an angle and a cardinal direction. I have my east and my northern line, so I want to find this angle, the one that is north of the eastern line. I started east, I went north to get to it, so we're going to say that this is a north of east angle. To solve for the angle, I simply go back to my trig. I know that the tangent of the angle equals the opposite, 19.27, divided by the adjacent, 51.49. I can take the inverse tangent to solve for the angle. Angle equals tan to the negative 1 of 19.27 divided by 51.49. And you will find that the angle ends up equaling a lovely 20.5 degrees. Again, check this in your calculator. Make sure you're in degrees mode. We fill this in, we've solved this difficult problem. Now, remember that this is the complicated stuff. We've gone from the easiest to the hardest in the course of about a half hour. Tomorrow we're going to spend a lot of time in class going through all of these different parts, starting easy and then progressing up to the more difficult. Thanks, guys. I hope you have a wonderful evening.